Hi everyone, myself Dr. Lakshmi Prasad, working as an associate professor in the Department of Data Science in Institute of Aeronautical Engineering, Hyderabad. In this video, I'm going to discuss about random variables. So, random variables is nothing but a variable, so whose possible values are going to be numerical outcomes of a random phenomenon. And there are two types of random variables. So, first one is discrete random variable, and second one is that continuous random variable. So these random variables mainly going to be used in discrete mathematics. So for that, the need of a random variable is very important. Normally, this random variable is going to be written as in the form of x, and this is also a variable. So, but here whose possible values should be the numerical outcomes of the random phenomenon. Okay, so there are two types of variables. So first one is discrete random variable, and second one is continuous random variable. So let's see one by one. So discrete random variable. So discrete random variable is the one which may take on only a countable number of distinct values such as 0, 1, 2, 3, 4. And these discrete random variables are usually a counts but not necessarily. And some of the example is that so number of children in a family, and then Friday night attendance at the cinema. It's a number of patient doctors seen in one day, a number of defective light bulbs in the box of 10, a number of head flips in the 3 tray. So there should be a count here. So the discrete random variable is one which may take on a countable number of distinct values. Okay. So if anything is should be the countable one, then it should be treated as a discrete random variable. So this discrete random variables usually counts. Okay. So like number of players in basketball game, and number of students attended today class. So these and all will be the countable ones. So all these things should be considered as a discrete random variable. And probability distribution. So for discrete random variable is nothing but a list of probabilities so associated with each of its possible values. So considering a tossing a fair coin 3 times, so I can able to find the probability distribution of that. So the probability distribution of the discrete variable is nothing but the list of probabilities so associated with each of its possible values. So for example, so if I'm going to toss a fair coin 3 times, so one side is head, other side is tail, other side is head. So these are the 3 coins. So if I going to be tossed these 3 coins 3 times, so what is the probability of getting this? I have to find it out. So let x is the value, discrete variable. So I want to find what is the probability of obtaining the number of heads here. So what is the probability of getting the number of heads here? So if x is equal to 0 means the probability of getting the head 0. So what are the possible number of cases? So if I'm going to toss all this, will be getting tail. So there is no head here. So there should be, this is the one of the chance. And similarly, if I'm going to be tossed 1, that means obtaining the head 1 time. So how many number of ways are there? So one is one head, so remaining 2 tails. So first one is head, second coin is first one is tail, second one is head, and third one is tail. So again, next one is TTH. So the 3 possible outcomes are appear. So getting one head. Okay. So similarly, if I'm going to be, what is the probability of getting 2 heads here? So for getting the 2 heads here, what are the possible chances? So first 2 coins will be head, and next 2 coins will be head, and and another one is that first one is head, and second one is tail, and third one is head. So this is the under probability. So obtaining two heads here, and this is one head, and this one is no head. And what is the probability of getting the three heads here? So what is the probability of getting three heads? So what is the only one chance we're having? So all the coins showing that three heads, then it should be that. Okay, so for the values here, so what is the probability of obtaining only one head here? So total number of uh, how many number of rotations are there? So totally 8 possibilities. So 1 2 3 4 5 6 7 8. So out of these 8 possibilities, so what is the probability of getting 0 head? So that should be 1 by 8, and obtaining one head, that should be 3 by 8, and probability of getting two head, that should be 3 by 8, and probability of getting three heads, that should be 1 by 8. So like this, we are going to be calculate the probability of any discrete random variables associated with different possible values. So if I'm going to plot the values, so obtaining 0 head, 1 head, 2 heads, and 3 heads. So based on that, so I'm going to get one option, and so this should be the 3 by 8. So that is 3 possibilities are there, and obtaining 2 also 3 possibilities, and obtaining 1, that should be 1 possibility. So like this, we can able to construct the bar chart also as well. So next one, so rolling the dice, what how we're going to calculate the probability distribution of this. So if I'm going to roll a pair of dice, and we have to record the sum of each try. So after the infinite number of times, so a distribution will be approximate the probability distribution, right? So that should be on next slide here. So if I'm going to roll a dice, so we're going to have what are the possibility of getting a dice, what are the possibility of getting the values here. So first one getting option getting 1, and if I'm going to get option 2, option 3, 4, 5, 6. So totally 6 possibility may come, right? So the probability of getting dice here, so what are the 6 possibility are going to get it. So if I'm going to roll a dice, so what is the probability of sum getting here? So see here, so probability of getting 2, so one dice is 1 and another dice is 1. And similarly, probability of getting 3, so one dice is 1 and the dice is 2, or I can able to get one dice is 2 and the dice is 1. And similarly obtaining the 4, so these 2, or I can able to get 2 2, I can able to get 3 4. Obtaining the value of 5, so 4 1, 3 2, 3 2, and 1 4. So based on this, we are going to be calculate the probabilities of rolling a dice here. So how can able to estimate this probability value? So if I'm going to roll 2 dice, so what is the 6 possibilities? So 1 by 6 into 1 by 6. So I'm going to get what is the possibility of getting 6 events. So probability of obtaining 1, so 1 by 6. Probability of getting 2, 2 by 6. Probability of getting 3 by 6, 4 by 6, 5 by 6, and 6 by 6. So this should be the 2. So 1 by 6 into 1 by 6, that should be 1 by 36. So this is the probability of getting 1 here. So if I'm going to probability of getting 2, if I'm going to roll 2 dice here. So similarly, if I'm going to roll 2 dice simultaneously, 2 by 6 into 2 by 6, that should be 4 by 36. So like this, we are going to be drawn all this probability distribution of rolling the dice. And the discrete random variable, how can able to do that? So for here, the discrete random variable x takes the fixed set of possible values with gaps between them, and the probability distribution of this discrete random variable x is going to list the set of values here and then probabilities. So this is the table what I shown previously. For all the elements, for all the values, there should be corresponding probability here. So here the Pi must satisfy two requirements. So every probability Pi is the number between 0 and 1 only, and some of the all probability should be matches to 1 to find a probability of any event. So we have to add the probabilities of a particular values and then make up the event. Okay. So these are the two requirements what are going to be remembered. So in order to the probability what we're calculating, so must satisfy the two properties, and all the properties should be lies between 0 and 1, and the sum of all this probability should be 1 here. So that is the two requirements we have to be remembered. And describing this probability distribution. So while analyzing this discrete random variables, we are going to follow some strategy in order to use this quantified data. So which is going to be describe the shape, center that it should be the mean, and spread that should be the standard deviation, and can able to identify any outliers also. So we are going to be analyze the discrete random variable. So for once we can able to draw this probability distribution that bar graph. So the mean should be this center of the graph, and spread should be the standard deviation, and we can able to describe the shape and outside the outliers as well. So let us take a simple example. So I want to find the baby's health at birth. So showing that the probability distribution of X is legitimate, make a histogram of the probability distribution and describe what you can able to see, and we can able to calculate the values where probability of X should be greater than 7. So here we are going to have some list of values, so 0 to 10, and then probabilities are given. So probability of obtaining, and I want to find the probability of X that should be greater than 7. I want to find it out. So first what we have to do that is, so all the probabilities between 0 and 1, and the probability sum should be 1. This is the legitimate probability distribution. So that one have to check it out first. So whether all probabilities are lies in between 0 and 1. So this is 0 and 1 only. So this is also 0 and 1. So all the probabilities values should be 0 and 1 only. And next requirement, the sum of all the probabilities should be equal to 1. So if I'm going to add all this one, so 0 0.001, 0 0.6, 7, 0 0.08. So if I'm going to add all these probabilities, so that should be equal to 1. So that is the second requirement. Then make a histogram of this, so probability distribution. So in the question itself, it suggests that the probability should be greater than 7. So what is the probability of greater than 7? So that means we are going to add all these values greater than or equal to 7. So 7 to 9. So if I'm going to add all these values, I'm going to get this value. So that means we're going to get a 91% chance of randomly choosing a healthy baby. Okay. So once you plot this diagram for this histogram for this, so you can able to understood so how far this health of the babies will be at the birth, you can easily estimate. So if the low is less, so we have to predict the baby's health, that should be this also you can able to understand. Then how I calculate the mean of the discrete random variable here. So the mean of the discrete random variable is the average of all possible outcomes, so where each outcome is going to be weighted by the probability. So suppose that x is a discrete random variable and whose probability distribution is this one. So value x1, x2 and x3 and probability p1, p2 and p3. So have to find the mean of expected value. So that should be multiplied by each possible value. Then you can add all the products here. So this is the initial table we are going to have. Then how we are going to calculate the mean. So the mean should be the summation of xi and two pi values. So xi value and the probability value. So here what I'm going to say that so the mean should be represented as mu x. So that should be the sigma of x. So that should be written as x1 into p1, x2 into p2, x2 into p3 and so on. So simply I can able to write sigma xi into pi. So this is the mean value of this discrete random variable. So let us consider how we are going to calculate this EPAGAR scores. And for this, so this is the list of values here. So how can you able to calculate the mean? So in calculating the mean, so we can able to write it as so mu of x is equal to so 0 into 0.001 plus 1 into 0.006, 2 into 0.007, 3 into 0.008, 4 into 0.012. Like this we can able to add up of all the equations. So based on this equation what I told, the sum of xi into pi values. So by seeing this, so if I'm going to write all these values here like this, then I'm going able to get the mean value here. So what is this mean value? So the mean value is going to be randomly selected chosen score value is 8.128. So this is the long-term average of the score of many randomly chosen babies here. And how are we going to estimate this standard deviation of discrete random variable? So in this one, so the definition of the variable is similar to the definition of the variance of set of quantitative data. So to get this standard deviation of the random variable, so we have to take the square root of the variance. So previously I told how we're going to calculate the mean value here. So mu of x. Now I can able to describe how we're going to calculate the variance of this discrete variable. So what is the equation of this one? So in this, the definition is that so the variance of this random variable is almost similar to the definition of variance of set of quantitative data. So in order to get the standard deviation, have to be take square root here. So the square root of variance have to be applied. Let's suppose that we are going to have a variable x is a discrete random variable, and whose probability distribution is that? So just now what I told. So the set of values is x1, x2 and x3 and probability is p1, p2 and then p3. So the means you know, so how can able to calculate the mean? So now how can able to calculate the variance? So for this the equation is that so we can able to write variance of x, I can able to write sigma x square also. That means what is the sigma value here? So x1 minus mu x whole square plus x2 minus mu x whole square plus into p1 into p2 x3 minus mu x whole square into p3 and so on. So simply I can write sigma xi minus mu value whole square into p1. Okay, so this is the equation obtaining the standard deviation of the discrete variable. Okay, so how can I able to do that? So take the first value, subtract the mu value what I obtained, apply the square and multiply with the p1. So similarly this is the first one, and similarly x2 minus mu x whole square into p2, that should be the second one. x3 minus mu x whole square into p3 should be the third one. So like this we are going to be estimate this mu of x into whole square into pi. So now, so this is the equation, right? So substituting this uh, values previous example into this equation, so what is we're going to get here? So here, so 0 minus xi minus mu value, what I have done previously is 8.128 into p1, so that should be the first one, and 1 minus mu value into pi, that should be p1, to the second one. So like this we're going to add a sum of all the values, so 10 minus mu whole square into 0.053, then we can able to get the variance. So if I'm going to apply square root of this, then I can able to get the standard deviation value. Okay, so first we have to calculate the mean and we have to calculate the variance, sigma square, and for standard deviation you have to apply the square root of variance. So the standard deviation is that 1.47, and then average, the randomly selected baby above score value should be lies between 8.1 to 8, that should be the, that is the value. And next one is continuous random variable. So what is this continuous random variable? So the continuous random variable is one which takes an infinite number of possible values. So the continuous random variable are usually measurements. So example, height, weight, and amount of sugar in an orange, and then time required to run a mile. So this should be the example. So the continuous means, so where the value of this variable is changes with respect to time. So the continuous variable is one which takes an infinite number of possible values, and the continuous random variables are usually the measurements. So height, I can able to measure in centimeters, weight in kgs, amount of sugar in an orange kg, and milligrams, and the time required to run. So if I'm going to take a child, so what should be the height in second year? What is the height in third year, fourth year, like this? So if I'm going to take, so the amount of sugar also going to be changes. So in one orange it should be 1.2 milligrams, and another orange it should be 0.95, and another orange it should be 0.5, like this. This is going to be changed, right? So this kind of variable should be treated as a continuous random variable. So this continuous random variable takes on all values in an interval of numbers, and the probability distribution of x should be described by the density curve. So the probability of any event in the area under the density curve and above the value of x that make up the event here. So continuous random variable takes on all the values in interval of numbers, and the probability distribution of x is going to be described by the density curve. So here the probability of any event is the area under the density curve. So the area in between the density curve. So this is the probability of the event by plotting this probability distribution curve. So normally this continuous variable is not defined as specific values. So instead it is defined over the interval of value. However, you can able to calculate the probability of a range of values. It is very similar to z-scores and normal distribution calculations. Okay, so the continuous variable is not defined at specific values, and it should be defined over the interval of value. So however, we can able to calculate the probability of range of values. So it's almost all similar to the z-score, so on the normal distribution calculation. So take an example, I want to calculate this young woman's height. So the height of young woman can be defined as a continuous random variable y. So with the probability distribution of n, that should be the value 64. So now question is that, so what is the probability that randomly chosen young woman height is in between 67, 68 and 70 inches. So, so the probability of young woman height in between 68 and then 70. So that is the question they asked. So for this one, so what we have to do is, so first we have to calculate the Z score. So how can able to obtain this Z score? So in between 68 and 70, right? So first, what is the minimum value obtained here? 64. So the normal curve height is mu value is 64. So for that, I'm going to calculate. So 68 minus mu divided by standard deviation. So that is 1.48. And then for 70, the Z score value is 70 minus mu value divided by standard deviation. So I'm going to get. So that means I'm going to get the probability values in between 1.48 and to 2.22. So what is the value that is less than Z value and then less than 1.48? So this is the value obtaining from the Z score values book, and finally I'm going to get this value. So that means that we're going to get a 5.6% chance that the randomly chosen young woman's height is in between 68 and then 70. So like this we're going to be estimate. So based on the Z score, I am going to calculate this value. So how the Z score is going to calculate it? So the value minus the mu value, that should be given as 64 divided by standard deviation, that should be 2.7. And similarly, another one is 70 minus 64 by 2.7. So in between this, I am going to calculate the Z score value. So the Z score should be less than 2.2 and it should be less than 1.48. The value is given as 0.9868 and another one is 0.9306. You finally get this one. For making percentage, I'm going to get 5.6% of angle. Suppose the height of angle can be defined as continuous random variable y, so with the probability distribution n. So the question is that at 70 inches tall, is Miss Daniel usually tall? At 70 inches tall, is Mr. Daniel usually tall or not? So the height of angle should be defined as y, and this is the mu value and sigma value. So what is the probability of y that should be less than 70 in order to get the tall of this angle man, Mr. Daniel? So how can I able to do that? So 70 minus 64 divided by standard deviation, I'm going to get 2.22. So the probability value is 0.9868. So that means Mr. Daniel usually 98.68% of population is shorter than. So among this all, so the Daniel usually tall because of 96.68% of the population is shorter than height. Okay, so like this we're going to be estimate this Z score value. So like this we're going to calculate the different types of variables in probability distribution. So we're going to have a random variable. So this random variable is going to specify the set of values among that should be the numerical outcome of the random phenomenon. And two types of random variables are available. So first one is discrete and second one is continuous. So a discrete variable is the one which may able to take among the countable number of distinct values. And these discrete random variables are usually the countable one, like number of players in basketball game, a number of students attended today, the number of patients doctors seen in one day, like this. So the probability distribution of the simple example I told. So how can I able to calculate this tossing a fail coin 3 times. So here x is the discrete random variable, so that means obtaining the number of heads. So if I'm going to take the 3 points, so the probability of getting 0 heads, 1 head, 2 head, and 3 head. So the possible outcomes is 8. So out of that, I'm going to calculate the probability values of each and every value. And rolling the dice is the another example I've taken. So if I'm going to roll 2 dice, so what is the probability of getting 2, 3, 4, 5, 6, 7, 8, 9, 10 like this? So for that, I'm going to have to calculate the probability value as well. And discrete random variable. So for the discrete random variable, have to be calculate the mean and standard deviation. So what are the equations for that? We are going to calculate that. So I take an example of baby's health. So here I'm going to calculate the probability value of x that should be greater than 7. So for this, initially I have to find 2 types of requirements. So first one should be all the probability values should be lies between 0 and 1, and the sum of all the probability should be 1. And so what is the equation for calculating the mean of this discrete variable? So mu of x is the symbol for representation of mean. So how can I able to calculate this? So x1 into p1, x1 into x2 into p2, x2 into p3, like this we are going to continue. And final equation is that sigma of x of I into pi. So substitute all the values according to the equation so that we can able to obtain the mean here. And once the mean is obtained, then how to calculate the standard deviation. So the equation for obtaining this is sigma xi minus mu of x whole square into pi. So this is the variance value. So normally represented as sigma x square, or I can write variable of variance of x. So the equation for that is xi minus mu of x whole square into pi. So once we are going to substitute all this, we can able to get the variance. In order to get the standard deviation, we have to apply the square root here. So this is the variance value. In order to obtain standard deviation, what I'm going to get is we have to apply the square root to the variance, then I can able to get the standard deviation. And next one is continuous random variable. So is one which is going to take the infinite number of possible values, like the height of the children, which may vary for year by year, and weight is also going to vary, and the amount of sugar in every orange, and the time required to run a mile. So this should be everything depending on the time. So the values are going to be changes based on the time, and it should also going to take infinite number of values. So the density curve, the area before that's under the density curve should be considered. And here also we're going to calculate previously mean and variance. So while considering this continuous random variable, we have to be calculate this Z score. So I'm going to consider example like young woman's height. So in this one, I'm going to calculate probability of young woman in between 68 and 70. So how can I able to calculate the Z score here is, so the value minus mean value by standard deviation. And similarly, I want to find the probability should be less than 70. So same equation Z score I have to calculate, and I'm going to get this value. Based on this, I can able to estimate the percentage. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.